Yeah, hello guys. We are meeting once again. I'm starting off with Power Machines N5. Our topic is gas processes. If you look at question 2, it reads, air in a cylinder has a pressure of 95 kilopascal and a temperature of 38 degrees Celsius. The air is compressed according to the law PV to the exponent of 1.24 equals to C until the pressure is 650 kilopascal. The initial volume of the air is 1.25 meter cubed. Our gas constant is given as 0.287. So let us just summarize the data of what we are given. We are given our P1, which is given as 95 kilopascal, and then we are also given our T1, which is given as 38 degrees Celsius. So we need to convert 38 degrees Celsius to Kelvin, so it becomes 38 plus 273, which gives us 311 Kelvin. We are also given the law. In other words, it becomes a polytropic process, because we know that if you look at our exponent here, polytropic process in practice, it ranges up to an average of 1.3. So if you look at 1.24, it's quite closer to 1.3. Remember, we have two processes which are similar to each other, which is a polytropic process and an adiabatic. And the average exponent of our adiabatic, it ranges up to 1.4. So this one, because it's PV to the exponent of 1.24, is quite closer to 1.3. Therefore, it becomes a polytropic process. Our N, in this case, it's 1.24. And then our P2 is given as 650 kilopascal. Our initial volume, our V1, is given as 1.25 cubic meters. And then our gas constant, 0.287 kilojoules per kg Kelvin. So the first question says, which carries 4 marks, calculate the mass of the air. Therefore, on 2.1, we can use our formula PV equals to MRT. So we have P1, we have V1, we don't have our mass, we have our gas constant, we have our T1. So we can substitute. We said P1 is given as 95, our V1 1.25. We are looking for our M, gas constant 0.287, our T1 311. So our mass, in that case, it becomes, we substitute, it becomes 95 times 1.25 over 0.287 times 311. So we are getting 1.33 kgs. That becomes our mass. And then the second question, they are asking us to calculate our V2. So we can use many formulas, but I think this one becomes easier. On 2.2, we can use P1, V1 to the exponent of n equals to P2, V2 to the exponent of n. Now we have everything at our disposal with the exception of our V2. So we can therefore say V2 equals to V1 into P1 over P2 to the exponent of 1 over our n. V1 is given as 1.25, and then our P1 is given as 95, our P2 is given as 650 to the exponent of 1 over our n, which is 1.24. So let's substitute there. 1.25 times 95 divided by 650 to the exponent of 1 over 1.24. I'm getting 0.265 cubic meters. Now we have our 2.3. They want us to calculate the final temperature of air after compression. So after compression, we have a number of formulas which you can use. We have a number of formulas which you can use. P2 V2 equals to MRT2. If we use this one, it will work because we have our P2, we have our V2, our mass, we've calculated it, our gas constant is there, so we can easily get our T2. So P2, we said is 650, our V2, 0.265, equals to our mass 1.33, our gas constant 0.287, times our T2. So from there we make our T2 a subject of the formula. So it becomes 650 times 0.265 divided by 1.33 times 0.287. So we are getting our T2 as 451.259 Kelvin. And then lastly, they are asking us to calculate our work done. No, but maybe before we go there, we have other formulas which can use to get our T2, but I think we can just, for the sake of time, we can just use this one for now. And then our 2.4 formula for calculating work done equals to MR into T1 minus our T2 over N minus 1. We can use this one because we have our mass, which is 1.33, our gas constant 0.287, our T2 and our T1. We've calculated everything. Now, because of my space here, we have our T1 as, we said our T1, it was given as 311, I think it will fit, minus 451.3. I'll round off to 3 in this case because to write 259, my space is becoming a bit limited. Our N is 1.24 rather, 1.24 minus 1. So let's substitute 1.33 times 0.287 times 311 minus 451.3 over 1.24 minus 1. I'm getting minus 223.141 kilojoules. Now we can also use the second formula to check whether what I got here is correct or is not correct. We can use our formula work done equals to P1 V1 minus P2 V2 over N minus 1, which becomes P1, it was given as 95. Our V1, we said it was given as 1.25 minus our P2, 650 times 0.265 over 1.24 minus 1. So let's substitute to get our answer. We have 95 times 1.25 minus 650 times 0.265 over 1.24 minus 1. I'm getting minus 223.141 2.92 kilojoules per other kilojoules. So you can see that the difference between our first method and second method is quite narrow. So which is to say the options that we used are fine. Thank you so much. We'll meet on the next question.